everyone, welcome to the part 2 of Ethernet and ARP. In this video, we are going to talk about ARP, that is the Address Resolution Protocol. First of all, we will talk about the ARP caching. So basically, there is a difference between the ARP command and the ARP protocol. The ARP command is used to view and manipulate the contents of this cache. Since the ARP command and the ARP protocol have the same name, so don't get confused. And the ARP command is used to view and manipulate the ARP cache contents, while the ARP protocol defines the format and the meaning of the messages sent and received and defines the actions taken on message transmission and received. So basically what we have to do, first we need to clear our ARP cache. For this, we will go to the command prompt. We will type ARP-A. So here you can see the interface, the internet address, the physical address and the type. Then for the clearing, you need to write this command, that is the ARP-D space star. So here I have cleared my ARP cache. Now I will open this file which I have already downloaded in the part 1 and I'll solve the following questions. I'll open my Wireshark, opening the file Ethernet Ethereal Trace 1. Here I have opened it. Now I will click on the Analyze, then Enabled Protocols, and then type IPv4. Here I'll uncheck this box because we do not require the upper layers. So this is what my desktop looks like. Now, the 10th question asked is, what is the hexadecimal values of the source and destination addresses in the Ethernet frame containing the ARP request message? First of all, we will go to the ARP request message, which is our packet number 1. Here, we need to find the source and destination address. Here is the source and here is the destination. The hexadecimal value for the source is 00 colon D0 colon 59 colon A9 colon 3D colon 68, and the destination value is FF colon FF colon FF colon FF colon FF colon FF. These are all the Fs, which indicates that this is the broadcast. Now, 11th question. Give the hexadecimal value for the 2-byte Ethernet frame type field. What upper layer protocol does this correspond to? So, first of all, I will look for the type field. In going back to Wireshark, looking for the type field, here is my type field, that is ARP, and its hexadecimal value is 0x0806. You can also see that it is of 2 bytes here, that is 08 and 06. Now the 11th question. If you want to know about the ARP specifications, you can go to these links, but we will directly go to the questions. How many bytes from the very beginning of the Ethernet frame does the ARP opcode field begin? For this, you need to go to the opcode. You need to search in the ARP, you need to expand it. Then search for the opcode. Here is the opcode, that is request and 1. You need to start, you need to see here, that is the blue. You can see here, that is, the value is 0001. And if you will count from start, it will be the 20 bytes. So the answer is 20 bytes. Now the question B, that is, what is the value of the opcode? The value of the opcode was 0001, that is the request. Now, does the ARP message contain the IP address of the sender? We will go to the ARP message. Yes, of course it does, because if we will the source, if we will see the source, then this is the address of the sender, that is my computer. So the answer is yes. Now the D question. Where is the ARP request does the question appear? The Ethernet address of the machine whose corresponding IP address is being queried. We will we have to find the question. In the packet 1, you can see here is the question mark. Who has 192.168.1.1 question mark? Tell 192.168.1.105. Here under the ARP, you need to look for the ARP target MAC address. So, we can conclude that the ARP packet structure includes the several fields, and the ARP hardware address field is specifically where the ARP request indicates the Ethernet address that corresponds to the IP address being queried. This field is basically of 6 bytes. Here you can also see that this is of 1, 2, 3, 4, 5, 6, 6 bytes, and is used to specify the hardware address of the target machine for which the ARP request is seeking to resolve the corresponding IP address. Now moving towards the next question, 13th one. Now find the ARP reply packet. Here we have seen the ARP request packet. Now here we will see about the ARP reply packet. First of all, we need to look for the ARP reply packet. So basically the packet number 2 is the ARP reply packet. ARP reply. Now answering the questions. Question A. How many bytes from the very beginning of the Ethernet frame does the ARP opcode field begin? Again we need to look for the opcode field and the reply to. The value for this is 0002, and the answer is again the same, that is the 20 bytes. What is the value of the opcode field within the ARP payload? As I have already told you, the opcode value is 0002. Where is the ARP message does the answer to the earlier ARP request appear? The IP address of the machine having the Ethernet address whose corresponding IP address is being queried. Now, we need to find the answer. The answer for this is here. 192.168.1.1 is at 00:06:25:DA:AF:73, and which is nothing but the sender's MAC address. And here is the sender IP address. Now the 14th question. What are the hexadecimal values for the source and destination addresses in the Ethernet frame containing the ARP reply message? ARP reply message, we need to find the source and the destination addresses. Here is our ARP reply message. So the source is this and the destination is this. The hexadecimal values for the source is 00:06:25:DA:AF:73, and the destination hexadecimal value is 00:D0:59:A9:3D:68. Now, what does the next question says? We have to open this file which I have already opened. We need to focus on the first and the second ARP packet in the trace corresponding to the ARP request sent by the computer running Wireshark and the ARP reply sent to the computer running Wireshark. why the computer within the ARP requested Ethernet address. But there is yet another computer on this network as indicated by packet 6, another ARP request. Why there is no ARP reply in the packet trace? So look at the packet 6. Basically, the destination is broadcast. So the answer for is this: the destination is broadcast, so it doesn't know who has the IP Ethernet address. We have completed the ARP part also. So this was till here about this video, and thanks for watching.